The research that I do is in elementary particle physics, and some people these days refer to that as high energy physics. And basically the idea is that we use interactions amongst what we think are fundamental particles to study the laws of the universe. The way that we do that is we use what people kind of frequently refer to as atom smashers, or what we call particle colliders. So what we do is we put together beams of particles, usually protons or electrons. We collide them. We use those new observations and we try to discern how the laws of physics behave. What we do then is we compare that to theories that we have on how things should work. So you either have a theory that really explains everything, or you've got some missing pieces. And that's one of the things that I focus on, is one of those missing pieces to the puzzle of how we understand the universe, and that's what we call the Higgs boson. The way that the Higgs boson works is that the theory that we have that explains, so it explains a couple of things. It predicts the particles that we should have. You know, we're made out of protons and neutrons and electrons. Protons and neutrons are made out of quarks. All of these things interact via different kinds of force carriers. So now the theories that we have they predict those particles and describe how they should behave. But there's one problem, is that the theory only predicts massless particles. And you and I are sitting here, I'm very massive and the gravity is pulling me down. Without something to explain why that should be there, the theory breaks down. Higgs boson, the basic idea is that the universe is filled with a quantum field. And the quantum field, the basic quanta, the excitations of that field are the Higgs boson itself. You can imagine you have a room full of, I don't know, say partygoers. Say it's a cocktail party. And everybody's sort of standing around talking to each other, sort of, you know, mingling a little bit. All of a sudden the door opens and somebody famous comes in. He's going to be immediately mobbed by everybody in the room. They want to talk to him, they want to get next to him. So all of a sudden he's got this crowd of people around him. Somebody like me walked in, I could just pass right through the room. Between the two of us, that crowd has selected out an interesting property. So he is famous and I'm not. So the crowd recognizes that. If you take that analogy to particle physics, there are certain particles that have more mass and particles that have, in some cases, no mass. So the Higgs field recognizes this quantity, and by its interaction with that particle, gives it that property that we recognize as mass. It's too early to say whether we really found something or not, but at this point in time, you know, this is really getting very interesting, and we'll know by this summer whether, you know, the data is starting to support that or not. If we do find something, this is, you know, one of the biggest revolutionary steps in particle physics for, you know, a century.